Let's see. How about Boolean, did I click on any tube equals false? And if I did, then we'll say did I click on any tube is equal to true. And down here, if not, did I click on any tube, then add a new tube. By the way, there is no function called add a new tube. And here I'll say remove tube I, because I'm going to remove the tube I, and there is no tube I. And hey, let's just return here so we only remove one tube at a time. Doesn't it make sense if you click, you should only remove one tube? You can click again if you want the next tube to be gone. Up to you. Or you could get rid of that, and then if you click somewhere, all the tubes that are there will disappear. Whatever you want. That's how I do it. Let me rewrite this a different way and see if I'm hearing you.
Okay.
I'll say tube, the tube I clicked on equals null. Then I'll run through them all. Then here I'll say the tube I clicked on equals t. Then down here I'll say if the tube I clicked on is null, then add a tube, else remove tube, the tube I clicked on. Wait, that's not what I thought. Anyway, is that more what you're thinking? In the end, here's the answer to all such questions. If it works, then it's right. So yeah, really, and anything that really works in your head works in code too. I don't want people to have this idea that code is somehow special and you have to code things a certain way. Code is just the formalization of thought. If you think in your head something should work, and if it makes sense to you, it works. It does in code. Unless it doesn't, in which case your thinking was wrong. And by coding it up, that's a great way to find out what's wrong with your thinking, because you can see why it doesn't work. And if it doesn't work, you think to yourself, wait, that should have worked. What you do is you go through and you find out why it didn't work. Because there's a reason. There's always a reason. And once you know that reason, you'll realize, oh, my idea actually was dumb. Or, oh, there's a bug. I didn't code up what I meant. I meant this, and then you code it up, and then it does work. So yeah, if you have a way for it to work in your head, it will work in code. And I'm happy with anything that accomplishes the click here to add a tube, click on an existing tube, and it goes away. And any way you want to do that is fantastic. Again, this comes down to the if it makes sense, it works. All things that make sense do work, or else they don't make sense. So yeah, if that is a reasonable solution to you, I recommend you pursue it. Don't try to do it my way. Try to do it your way and try to make it work. And in the process, one of two things will happen. You'll find out that it doesn't work, that your idea was wrong, or you'll make it work. Or you'll give up, but you should never give up, therefore that should never happen. Here's an important coding principle. Put variables where they belong. Where do they belong? Where they make sense. A controller should know if keys are up and down. Controller should know it has a buddy named the model. Controller doesn't know how many tubes there are or where turtles and Marios are. Does that make sense in your head? Marios should know where their position. Marios should not know the location of the nearest tube. That feels like that's the model's job is to know what's going on in the picture. Mario's job is to know what's going on in Mario. And the tube's job is to know about tubes, right? If your tube has references to controllers and Marios, you're doing weird stuff. Does that make sense? Okay. If things make sense, it's a lot easier for your code to mirror your head. And when your code mirrors your head, it's a lot easier for your ideas to turn into code. And that's what coders do. We take ideas, we implement them in code. And that's when coding becomes fun. When you suddenly have the power to concoct anything in the universe that you want, and you can suddenly formalize that in code and then watch it in action. You are a creator. You see why you want to get there? Make your code make sense. Keep it clean, add comments, etc. Okay. We did those. Let's talk about scrolling, and then I need to talk about JSON. Scrolling. Is that the job of the model, the view, or the controller? I think of it as the view because the way we usually picture Mario Land or any other side-scroller game is this. There's this big, long world, right? And Mario happens to be right here, and we happen to be looking at that spot of the world because we want to see Mario because Mario's interesting, right? But in our heads, there's still a Goomba way over here walking back and forth between the tubes. Now, there might not really be, because in reality, it's kind of a waste of computer processing power to sit there making that Goomba walk back and forth. So what really happens is when the view gets near it, the model wakes up and says, oh, let's make the Goomba start walking. You don't really keep it all alive, but at least in our heads, we think of the whole world as existing, and the view as just being a picture of that piece of the model, right? Therefore, should the model know where the camera is, or should the camera know where it's at? The camera should know where it's at. That just kind of makes sense in my head. Therefore, the scroll position belongs in the view. Now, enable the view to scroll over a model. Add a variable to the view class. Now, I hear state, add it to the view class. I really want you to put it in the view class because it makes sense. Now, the way this code is designed, you will notice, whoops, wrong folder, A1. Turtle, game, Java. I don't know if yours looks exactly like this, but here's how mine looks. I make a model. The model knows about nothing. I make a controller. The controller knows about the model. And I made a view, and the view knows about the controller and the model. Does yours look like that? Maybe it's a little different. I don't care. If you don't like it, fix it. Now, in order for the controller, when I press on the keys to tell the view, hey view, scroll left, view, scroll right, the controller needs to know about the view. Is that not so? Because the controller needs to be able to say, yo view, deal with this, right? So we're just going to have to pass a view into here, but now we have a bit of an issue. The view doesn't exist yet until right there. If I pass view in right here, what am I passing? Null. What's going to go in the stack is the value in this variable, which is a null. And when I come along later and I say view equals new view, is it going to go back in time and correct this value and instead, in the past, pass in the value of view? No, it's going to pass, it will have already passed in a null because time travel is impossible. So you can't really pass a null. We need to pass the view, so we're going to have to move the view up to here, right? Except now we have a problem because how do we pass the controller to the view and right? They got to know about each other. How are we going to do it? How do you introduce two people to each other? John meet Frank, Frank meet John, right? Wouldn't it be nice if the controller had some way of knowing about a view that didn't require passing it to the constructor? How about this? Now it does. This is called a setter. The idea of a setter is I can now say controller, meet view, or set view. If it makes you feel better, you can change it to be meet view. By convention, they use set in Java a lot. Setters and getters are the common convention for connecting things. So let's go with conventions. They're usually good. There we go, set view. So now I come back down here to my game and I say, make a model, make a controller, make a view. Oh, and by the way, controller meet view. And now the controller has a pointer to the view has a controller, blah, blah. You know what I mean. The view has a point reference to the controller has a reference to the view. They can now yell at each other. The controller can say, view, deal with this arrow press, controller, deal with... Why does a view need a controller? I don't know. I can't think of any good reason right now. But mostly, you should be able to do this, so do it. Well, now that that's the case, I think the rest of that problem becomes super easy, right? I think so. Let's talk about JSON. I provided this code for you called json.java. Anybody have any idea what that is? By the way, usually when I give you code, I want you to look at it, understand it, penetrate it, become one with it. Not so with this one. This is a big, messy bunch of gobbledygook. If you want to read through it, more power to you. That would be awesome. But really, I'm just trying to provide functionality that you can plug into. I'm asking you to think abstractly now. I want you to use this without necessarily having to own it. Okay? Here's what JSON is. It's a text-based format. Let's draw a picture. And by picture, I mean write some text. In JSON, this is how we indicate an object. This is how we indicate an array. And objects have names and values. So you could say tubes is an array. And arrays will have inside of them lots of objects. Each of these objects is a tube. And a tube has inside of it an X position and a Y position. And look, I have a whole bunch of tubes all in exactly the same spot. There, now I have tubes spread at regular intervals across my screen. This is a JSON encoding of a model object that contains a member variable named tubes, which is an array that where each element is an object, and each of those objects has an X member variable and a Y member variable. And basically, in JSON, you can express pretty much whatever you want. JSON is designed for expressing object hierarchies. It's a really great way to encode stuff in memory. In other words, if you have a bunch of stuff and you want to serialize it into a document format, JSON is pretty much the world's best suited format for it. And so I'm introducing you to JSON. Yes, question? Yeah, so in Java we have things like dynamic arrays and static arrays, and we worry a lot about that. In JSON, it's a document format. Documents don't sit around doing anything. So because it's just going to sit there, at the time you create it, whatever size it is, you're going to make it that size, and it's going to stay there until you load it back into memory. And then you're going to worry again about whether it's a dynamic array or a static array. So JSON's goal is to be simple. Java's goal is to be useful and flexible and all that kind of stuff. So there really is no dynamic array versus static array in JSON. It's just, this is how you encode a bunch of stuff that's all the same. Here's the main thing I want you to get out of it. I have some code here. This is sample code. By reading this sample code, you should know how to write your code. Your code's going to look kind of like this. And so if you can read this sample code, this will tell you how to interface with all of this gobbledygook that you're just going to add to your project because I said so. Okay? So let's look at this. Class, submarine. This is obviously an example. There are no submarines in computers, but we all know submarines are either atomic or diesel powered, right? And they all have some crew size, and they can go to some depth, and they all have periscopes and a whole bunch of torpedoes, right? In theory, maybe it's a bad example, but see how I used a bunch of different types, Boolean and int and double and a class type and an array list. These are kind of the things you're going to be using, so this is a good example. Let's start with not the unmarshalling, but the marshalling. This is how we turn our objects into text. We start by making a JSON object. See, ob equals JSON.newObject. This function just calls new, by the way, in case you want to look. But this is going to make a JSON object, and I'm going to add a bunch of members to it. What I'm doing is I'm taking my objects in memory, and I'm encoding them in this JSON format, which, by the way, is also a bunch of objects. But the difference is, when I'm all done, there's a save method. And I can use that object to call save, and I can write it to a file, and it'll store everything in memory into that file. You see how that's useful? If you're going to make a map editor, you're going to want to know where all those tubes are. You're going to want to write it to a file. And I've done all the work for encoding it into a format and writing it to a file for you. So that's what this task is all about. Okay? that's all I've got time for today. Maybe we'll have time for questions about JSON on Thursday or on the forum. And anyways, happy coding and thanks for coming.